Hi there and welcome back to another Papetti Math YouTube video tutorial where today I am going to be teaching you, yes you, Algebra 1. And in this video we're going to finish up our lesson on factoring simple trinomials. And here's exercise number 5 that says, here's a mix of all types of trinomial factoring you have covered so far. Factor each of the trinomials completely. So let's start off with x squared plus 20x plus 100. So we look and we see, is there a GCF? And we always want to ask that question first. Is there a GCF? And the answer is no. So we want to open up two sets of parentheses, start each one off with x, because x times x gives you x squared, and find two numbers that multiply to 100 and add to 20. So 1 times 100, 2 times 50, 4 times 25, 5 times 20, 10 times 10. So of these, which would combine to give you a 20? And the answer is this last factor pair, and that's going to be 10 and 10. And what signs could I use to multiply to a positive 100 and add to a positive 20? And my answer is positive 10 times positive 10 is positive 100, and 10 plus 10 will give me 20. Now, we could also simplify this even one step further because x plus 10 and x plus 10 are the exact same factor. So there's a way to write that in shorthand, and that's x plus 10 squared, because squared means to take it and multiply it by itself. So we could rewrite that as x plus 10 squared. In part B, we're going to take a look at x squared plus 17x plus 72. And again, we want to take a look and see if there's a GCF. And I don't see a GCF, so we're good to go on to our next step, which is to open up two sets of parentheses, start each one off with x because x times x gives you x squared, and then find two numbers that multiply to 72, and those same two numbers add to 17. So I'm going to do this one without listing out my factors. If you want to pause the video and list out your factors to determine the pair, go for it. Okay. Now that you've had a couple seconds extra, if you pause the video to determine that, let's see. I'm going to get 9 times 8 here, because 9 times 8 is 72, and I could also get a 17 by combining a 9 and an 8. So how will I get a positive 17 and a positive 72? Well, that's easy because both of them are positive, so that means both of my factors are going to be positive as well. Okay. Going on to part C here, x squared minus 5x minus 36. And again, I don't see a GCF, so I'm going to go to my next step, which is to open up the two parentheses, start each one off with x. X times x will give me x squared. And what two numbers are going to multiply to 36 and combine to get 5? Well, I could think of it as 1 and 36, no. 2 and 18, no. 3 and 12? No. 4 and 9? 4 and 9, I could get a 5 from a 4 and a 9. Okay, so now I pay attention to my signs. After I get my factors of 4 and 9, now I need to really pay attention to the signs. How can I multiply to get a negative 36? Okay, that means one of them has to be negative. Which one? Well, I want to combine them to get a negative 5. So is that going to be 9 minus 4 or 4 minus 9? And the answer is 4 minus 9 will give me a negative 5. So my factorization here is x plus 4 times x minus 9. This brings us to part D. And on part D, again, we want to ask ourselves, is there a GCF? And the answer here is yes, there is a GCF. And all of these terms are divisible by 4. So I'm going to write a 4 and then open a set of parentheses. What remains inside those parentheses? Well, I divide each term by 4. And when I do that, I get 4x squared divided by 4 is x squared. 20x divided by 4 is 5x. And negative 24 divided by 4 is negative 6. So now that I have this left over, I look inside these parentheses and I see, is this factorable? So I'm going to open up two sets of parentheses, start each one off with x because x times x will give me my x squared. And what two numbers multiply to 6 and combine to 5? And my answer is 6 and 1, because positive 6 minus 1 will combine to get a positive 5, and 6 times negative 1 will give me a negative 6. Now, if you were thinking of 3 and 2, 3 and 2 could, in some scenarios, combine to 5, but in this scenario, we can't multiply to a negative 6 and combine to a positive 5 using 3 and 2. So be careful with that one. In part E, we have x squared minus 12x plus 36. I don't see a GCF, so I could go straight to the two parentheses. X is in the front because x times x will give me x squared. And what two numbers are going to multiply to 36 and combine to get negative 12? Not 1 and 36, not 2 and 18, not 3 and 12, not 4 and 9, but we're getting closer. Oh, 6 and 6. 6 times 6 can get a 36, and a 6 combined with a 6 could give us a 12. So now let's pay attention to our signs. We need to combine them to get a negative 12 and multiply them to get a positive 6. So we're going to be using minus and minus because negative 6 times negative 6 is positive 36. Negative 6 minus 6 is negative 12. So once again, these are the same exact factors, so we could rewrite this just like we did in part A. We could rewrite this as x minus 6 squared. And finally, we have part F here. In part F, we look for a GCF. Do we have a GCF? And our answer is yes, we do. Our GCF in this one is 4. And to see what's left over, we divide each of our terms by the GCF. And 4x squared divided by 4 is just x squared. 16x divided by 4 is going to be 4x. And negative 128 divided by 4 is going to be negative 32. And once again, now we're going to bring down the 4, open up two sets of parentheses, and see if the remaining terms are factorable. I'm going to start off each with x because x times x will give me x squared. And are there two numbers that multiply to 32 now and combine to 4? And the answer is yes, there are. And if I'm going too fast, remember, always pause the video to give yourself time to think of these numbers on your own. But I'm just going to say that 8 times 4 is 32, and I could get a 4 from an 8 and a 4. How can I do that? The answer is that I'm going to make this a positive 8 and this a negative 4 because 8 times negative 4 gives me negative 32, and 8 minus 4 gives me 4 in the middle. So once again, my final factorization here is 4 times x plus 8 times x minus 4. Now in this exercise, we combined everything we learned from GCF factoring to simple trinomial factoring, and even we learned how to rewrite if we have the same factor as that factor squared. And if this video is helpful in factoring these 6 trinomials, please give this video a thumbs up, and you're now ready for our next lesson on factoring a different type of trinomial, or something that looks different. Thank you for watching.